Okay guys, welcome back. So this is the second part of trigonometry, a series of lectures on trigonometry, and in the previous set of lectures I discussed about the basic trigonometric functions, the secondary trigonometric functions, and different categories or different identities, actually the 11 different identities that are used to identify some variables and some trigonometric quantities, and which also makes that the problems somewhat easy. And I discussed different examples through these concepts. So in this video I will be focusing on graphs of trigonometric functions. Now you may know graphs of trigonometric functions. Alright, so now first of all, before beginning this section, I invite you, if you don't understand some variable or some equation or some identity that is used in trigonometry, to simply visit those previous videos of mine and then come back to this lecture, because it will be very useful for you and it will be very easy for you to follow those lectures first and then come back here and learn from the beginning. Alright, so graphs of trigonometric functions. So you know that if you have a graph of something like y equals fx, say fx equals x plus 2 or something like that, it will be a linear, it's a linear expression. It will be somewhat in the graph in the form y equals mx plus c. And if you have something like y equals x squared plus 2x plus 5, it is in the form of y equals ax squared plus bx plus c. So you have drawn enough those graphs, and you are very familiar with it. Sometimes you may be familiar with even with the basic trigonometric graphs like y equals sin x, y equals cos x, and y equals tan x. But sometimes you may not know about these amplitude transformations or translations and phase transformations or translations that are basically used in problems when solving trigonometric problems. So whenever you got a problem, you may be thinking how to draw. You know y equals sin x, but you don't know what is meant by y equals sin x plus 2, or y equals sin x plus 2, or y equals 2 times sin x. So you don't know sometimes those things, and you have to get to know about those things. So those are the things that will be discussed in this lecture and in the series of lectures that are related to this topic, graphs of trigonometric functions. So first of all, I think most of you guys know what is meant by the graph of y equals sin x, y equals cos x, and y equals tan x. But there may be some guys that who don't know about these graphs. So I will begin by drawing those graphs, and then I will go to the complex problems. Okay. So first of all, I will draw the graph of y equals sin x. So this is the x-axis and this is the y-axis, and I will draw the graph only in the period of 0 to 2, 5. So this is 0. I'll take this as 5 by 2. This is 5. This is 3 5 by 2. And this is 2 5. So the sine graph varies between plus 1 and minus 1. So the maximum amplitude is plus 1 and the minimum amplitude is minus 1. So it's actually the displacement from the, is called also called the mean position, the x-axis. The distance from the mean position is the same for particles or for atoms or something like that, which are on this sine graph on both axes. So actually what happens is that when you have a curve like this, you just flip it over the other curve and just connect it to the final point of the first curve. So actually the maximum amplitude is plus 1 as I said before, and the minimum amplitude is minus 1. So So the sine graph will be like this. And 0 sine 0 is 0, sine 5 by 2 is sine 90, sine 90 sine 90 is equal to 1, so we read this here 1. Sine 5 is equal to sine 180 is 0, so this will be the 1. And sine 35 by 2 is sine 270. When sine is in 270, it will be in the third quadrant. It's the beginning of the third quadrant. You can write sine 35 by 2 as sine 5 plus 5 by 2. And when sine is in the third quadrant, it's negative one. So it's actually sine 5 plus 5 by 2 is actually minus sine 5 by 2. So sine 5 by 2 is 1, as I said before. So sine 35 by 2 is also minus 1. And again, sine 25 is sine 360. I told you during the course of quadrants, sine 0 or any angle, for any angle, because the total angle around a point is 360 degrees, so the 0 degree point will flip over, or coincide or overlap the 0 degree line. So 0 degrees for any angle is also equal to 360 degrees, regardless whether it's sine, cos or tan. So sine 0 is equal to sine 25 or sine 360, and it will be 0. And it will go here. So sine 0 is 0, sine 5 by 2 is 1, sine 5 is again 0, sine 35 by 2 is minus 1, and sine 25 is 0. So the graph will be like this. Go like this, and you just flip it over from here to here, and you connect the starting point of the flip over the end point of the object. So y is equal to sin x is such a simple graph, and it will be easy. Sometimes you may know by now, and you know that y equals cos x as well, so I will draw that. Y equals cos x. So cos x at 5 by 2, 5, 3 5 by 2, and at 2. So cos x is also like sin x. The maximum amplitude is plus 1 and the minimum amplitude is minus 1. So I will draw only the graph between 0 and 2 by, that is 0 and 360. So first of all, I must mark the maximum amplitude and the minimum amplitude in order to draw a graph. So the maximum amplitude is plus 1 and the minimum amplitude is minus 1. So the graph will be like this, as I mentioned before. Actually, as mentioned in the co-function identities, sin x is equal to cos 5 by 2 minus x, or cos x is equal to sin 5 by 2 minus x. So actually what happens is just this graph, the y equals sin x graph, is just transformed 90 degrees. So if you have in the graph sin y equals sin x, x equals 60, then in y equals cos x, it will be 90 minus 60, that is 30. So cos 30 should be equal to sin 60, and it happens so. So what happens actually is in y is equal to cos x, it just transforms 90 degrees in this direction. So the y equal to cos x graph will be like this, and 0 cos 0 is 1, and 90 cos 90 is equal to 0, and 5 cos 5 is equal to minus cos 0. So minus cos 0, so that will equal to minus 1, as cos 35 by 2 is equal to plus cos 5 by 2, so that is equal to 0, and at 2 5 it is equal to cos 0, so that's the second one. So the graph will be simply like this. So that's y is equal to cos x graph. So what happens when y is equal to tan x? Y equals tan x. So y equal to tan x. So you know that when x is 0 in the y equals tan x graph, when x is 0, tan 0 is 0. So when x is 5 by 2, tan 5 by 2 is sometimes it's called not defined, sometimes it's called infinitive. So it's actually not a simplified value. So y equals tan x graph will be like this. I will not show you the same technique because it's somewhat complicated to decide about y equals tan x from the graphs of y equals cos x and y equals sin x. So y equal to tan x graph will be like this in the interval of 0 to 2 pi. So this is x, this is y, this is 0, this is 5 by 2, this is 5, this is 3 5 by 2, and this is 2 5. Alright, so this is y, x against the x is the angle against y, so x is the independent variable and y is the dependent variable. At 0, y tan x is 0, so y is 0. So at 5 by 2 it's equal to infinity, or it's not defined. So what we do is just the angle is beginner, we call that an asymptote. Asymptote is it just approaches but doesn't get to the line. So we call asymptote, sometimes you will know by now. So what we do is we draw a dotted line which goes through 5 by 2 and is parallel to the y-axis here. At 5, y equal tan x, so y equals tan 5, that's 0. At 3 5 by 2, again, that's y is equal to 90. So again, the same thing happens. So again, another dotted line. So the graph will be like this. It decreases as such and it goes like this. Oops. Like this. Alright, this is not wrong, right? This is wrong. Right? What happens is just a curve here. Alright, so that is y equals tan x. So those are the basic graphs that you may know by now sometimes, and sometimes if you don't know, I just explain what is meant by y equals sin x, y equals cos x, y equals tan x. But the length and breadth of this course doesn't limit to those graphs. So you don't know sometimes what is, as I mentioned before, what is y is equal to sin x plus 2. So what is y is equal to sin x plus 2? So sin x plus 2 is just shifting a graph upward, and y is equal to sin x plus 2. X plus 2 is the say the first graph is y is equal to sin x and the second graph is y is equal to x plus 2. X plus 2 means that the angle is increasing by 2. Angle is increasing by 2, and what happens to the graph? So I'll discuss those in the next video, and from the videos coming hereafter, we'll be focusing on the phase transformations and the amplitude transformations that I'll be discussing shortly. So see you then, and thanks for watching the video.